Welcome to all. The next property we have to discuss is the combined arithmetic formula. We have two sets of observations or two frequency distributions. One with the mean x1 bar and the another with the mean x2 bar, arithmetic mean x2 bar. Then their combined arithmetic mean is x bar equal to x1 bar plus x2 bar divided by n1 plus x2. So we have two frequency distributions, one with n1 observations and the other with n2 observations, and the corresponding means are x1 bar and x2 bar. Then the combined arithmetic mean is n1 x1 bar plus n2 x2 bar by n1 plus n2. So once again we have two sets of observations, so two frequency distributions, so that n1 observations in the first case, so we have x11, x12, etc. x1, n1. For the convenience, let me denote as n1 as here as k, with the corresponding frequencies f11, f12, etc. f1, n1, and mean x1 bar. Similarly, in the second distribution, we have n2 observations, x21, x22, etc. x2, n2. Here n2, instead of n2 I am writing m, with the corresponding frequencies f21, f22, etc. f2, n2, and arithmetic mean x2 bar. This is what we have, two distributions. Now in the case of first distribution, x1 bar means summation I equal to 1 to k f1i x1i by n1. Here k is n1. So sum of the observations multiplied by corresponding frequency. So since it's a frequency distribution, f1i into x1i by n1. So the total sum of the observations in case of distribution 1 is n1, that is nothing but summation I equal to 1 to n1 f1i x1i, that is n1 x1 bar. Let me to denote this as S1, this sum of the observations as S1. And similarly in the second case, in the distribution of the second distribution 2, the x2 bar, its arithmetic mean x2 bar is summation j equal to 1 to n2 f2j x2j by n2, so that this total sum of the observations becomes, that is the total sum is this f2j x2j, summation f2j x2j, j equal to 1 to n2, equal to n2 x2 bar. Let me to denote this sum as S2. That is the total sum of the observations. So we have two sets of observations, two distributions. So the total sum of all observations of both the distributions is nothing but S1 plus S2. That is summation I1 to N1 F1i into X1i plus summation I j equal to 1 to N2 F2j into X2j. Let me to denote this as S, the total sum of all the observations. Now how many observations are here? In the first set there are n1, and in the second case there are n2. So their sum is, let me denote as n, total as n. So total n observations. Now the arithmetic mean of the combined data, combined observation, all the observations, is nothing but S by n. S by n in the sense S1 plus S2 by n1 plus n2. That is our x bar. What is S1? S1 is nothing but n1 x1 bar, and S2 is n2 x2 bar. So their sum. So x bar equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. n1 x1 bar plus n2 x2 bar divided by n1 plus n2. That is the combined arithmetic. That's all. So this is a combined arithmetic. Now let us discuss the merits and demerits of arithmetic. First merit is the simplicity of this measure. Simplicity and it is easy to calculate. So the arithmetic mean is here, in fact, the arithmetic mean is calculated by summing all data points or all observations and dividing by the number of observations. This is straightforward calculation and make it easy to use and understand. Consequently, it is widely applicable. Commonly used in various fields apart from statistics, economics and other decision making sciences or all everyday life, everyday situations. We use mostly this type of average. That's the arithmetic. And also so that it has applications in numerous practical situations. Another merit is the foundation for other statistical measures like variance, standard deviation, etc. This is a mathematical problem. It's mathematically amenable or useful for further algebraic manipulations. This is another important merit of this average. Also, it represents a central tendency. In the sense, it provides a measure of the central value of the data. Or it gives, in other words, it gives a sense where the data tends to cluster. So so that it represents the data to a great extent. And also it is a foundation for other measures as mentioned earlier. The essential for many statistical techniques like regression analysis and hypothesis testing. There are several statistical methodologies that we use arithmetic mean as a good average. So consequently, this enjoys more properties which are desirable properties of a good average. Even though it has some demerits also. Some demerits are the sensitivity to extreme values, extreme data points or values. Extreme are outliers. The extreme values are also known as outliers. So heavily influenced by outliers or extreme values. Or for example, a single outlier disproportionately affect the mean, leading to a potential misleading representation. For example, once you have in a class, there are 10 students. Most of the students have got marks, say more than or 80 to 90%. But one of the student or one or two got marks less than 10. So these marks are outliers. So that marks affects the real typical average of that. So that it is heavily influenced by extreme values. Another, even though as a merit we mentioned that it is a representative, but not always. Not always a representative. For example, in skewed distribution, it is not asymmetric. There are skewness, positively skewed and negatively skewed. Such matters we will discuss later. So in such situations, this measure may not give or may not accurately reflect the typical value or considered as an average, or distorted by asymmetry of the distribution in the sense. And Also, it ignores the distribution of shape or does not convey information about shape or spread of the data. In fact, while we considering the central tendency, it is not a point, but it provides a central value, but not data distribution around it. Another thing is it is not suitable for non-numerical data. So it's not appropriate for categorical data or ordinal data, where values do not have a meaningful numerical differences. And another important demerit is its assumption of homogeneity, in the sense it assumes all data points are of equal importance and thereby contributes equally to the central value. This may not be appropriate for heterogeneous data, so that this type of a measure may not be appropriate for heterogeneous data. These are the important demerits. Okay. So we discussed we discussed the combined arithmetic mean. Once we have two sets of observations, then what about the combined arithmetic mean? With each has arithmetic mean we know, then how to find the combined arithmetic mean. And second thing, what are the merits and demerits of the arithmetic mean as an average. So even though arithmetic mean enjoys several desirable properties of a good average, it has certain demerits also, that also we mentioned. What about the merits and demerits? Okay, let us stop here. Thank you all. Thank you.